Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are first time viewing this channel and directly this video, then I will suggest you to go through my introduction video first to understand the presentation structure of the course content. Today we are at workshop 9 for the matrices. This is workshop 9 for the matrices. Okay. In this class, we will do the NCERT problems based on adjoint and inverse. Okay, NCERT problems based on adjoint and inverse. What is adjoint and what is inverse? We have completed this in our detailed explanation class. Please go through the detailed explanation class first before coming to this workshop session. For finding the inverse, earlier in one of the workshop session, we had completed with one of the method which is performing the elementary operations, row operations and column operations we will perform and we will find how to get the inverse. In this workshop session, by taking the adjoint, how to find the inverse, we will concentrate on those problems. In this workshop session, we will concentrate on how to find inverse by using the adjoint of the matrix, right? We will concentrate on those problems. Okay, so now let's get started. Okay, let's get started with my first problem. My first problem is asking about find the adjoint of the matrix. So what is the adjoint? Adjoint is cofactors transpose. Cofactors we have done in our previous workshop session 8 class. Please go to workshop session 8 class to find what the cofactors are. Okay. Now, and also detailed explanation class. In detailed explanation class, I had explained how to find the cofactors for a matrix. Okay. So let's find the cofactors for this. So cofactors for this. For first, it will be 4 positive because 1 is a11 it is. So minus 1 to the power of 1 plus 1. So it is positive. Here it will be negative. So cofactor will be minus 3. Strike out first row, second column. For this first row, first column. So you will be left with 4. So 4 is the cofactor for first element. For this cofactor is minus 3. For 3, strike out second row and first column. So you will get minus 2. Second row, first column. 2 plus 1 is odd, so minus 1 to the power of odd is negative, so it will be minus 2. And for 4, it will be 1 and it is positive. What is adjoint? Suppose this matrix is A matrix. Then adjoint of A will be cofactors transpose. Okay, cofactor transpose. You can write T also and you can write dash also. Okay, so it will become 4, 1, minus 3, minus 2. So we have done the transpose of this and we have got what is the adjoint. So adjoint is 4, minus 2, minus 3, 1. Okay, this completes the first part. In second part, we have to find the adjoint of the 3 by 3 matrix. So let's take this as A. In this part, we will find adjoint of this 3 by 3 matrix. So adjoint of A will be again cofactors transpose. So let's find the cofactors of this and do the transpose. Okay, so cofactor for 1, it is 3 minus 0. So first element it is 3 and it will be positive for 1, 1. Second element minus 1, it is negative. It is 2 plus 10, 12. So minus 12. After that, for next one, 0 plus 6. So it is positive. For this one, it is negative. 2 plus 10, 12. We have minus 12. For 2, it will be 0 plus 6. So it is 6. Right? Now for 2, it is minus 1, 0. So it is plus 1 because here it will be negative. Here the cofactor will be negative and cofactor of 2 is minus 1. So minus 1 means it will become plus 1 because here cofactor is negative. Here it is positive cofactor. So we have to strike second row, second column. So 1 1 is 1, 2 plus 2, 2 into 2, 4. So 1 plus 2, 5. And this will be positive. So it is 5. Next one is negative. Negative, here it is 0, minus 2. So minus 2, here it will become plus 2 because it is negative. Right? We will do the check again. 0 minus 2, it will be plus 2. Yeah. Next. For first or third column, here it is positive again. So positive minus 5, minus 6, minus 11. Minus 11. Again here it will be negative. For 0, the cofactor is 5, minus 4, 1, minus 1. Because here cofactor is negative. For 1, cofactor is 3 plus 2, 5. So here it is 5, positive. So this is cofactors transpose. So what will be my adjoint now? My adjoint will be this transpose we will do. So we will get 3 minus 12, 6, 1, 5, 2, minus 11, minus 1, 5. So this will be the adjoint A. Okay? Are you getting it? So what we had done? We had found the cofactors of each and every element, and after that we had done transpose of that matrix to get the adjoint. Okay? So this completes problem number 1. Let's move on to problem number 2. Let's move on to second problem. So second problem says that we have to verify that A into adjoint A is equal to adjoint A into A equal to that A into I. Okay? Where A is the matrix 1 minus 1 2, 3 0 minus 2, 1 0 3. If A is 1 minus 1 2, 3 0 minus 2, 1 0 3, then we have to verify that A into adjoint A equal to adjoint A into A. So let's first find what is adjoint A. So adjoint A will be cofactors transpose. So let's find first cofactor. Cofactor of 1 will be 0, 0. For minus 1 it is 9 plus 2, 11. 11 means minus 11. Okay? Because it is negative for second element. Third element cofactor will be positive. It will be 0. Now second row first element cofactor is minus 3, 0. So minus 3 it is negative. So it will become 3. For second row second column element 0. It is 3 minus 2, 1. It is positive. So it is 1. After that third element in second row it is 0 plus 1. So it is 1 and it is negative. So minus 1. Okay, 0 plus 1. Yeah. So it will be negative. So minus 1. For 1 the cofactor is positive. So it will be 2. And for 0 the cofactor is minus 2, minus 6, minus 8. Minus 8 it will be negative. So it will become 8. And for 3 the cofactor will be 0 plus 3. Okay, so it will be plus 3. Right? So this will be cofactors transpose. So this is equal to 0 minus 11, 0, 3, 1, minus 1, 2, 8, 3. So this will be the adjoint. Okay, this will be the adjoint. Now let's find what will be the that A. Determinant of A will be how much it will be. I will expand through column number 2 because I am having 2 zeros over here. If I will expand through column number 2, it will be minus of minus 1 because second element it will be negative, and 3, 3, the 9, 9 plus 2, 11. So it will be 11. So determinant of A is 11. What will be that A into I? We are finding this element. That A into I. So that A into I will be 11, 0, 0, 0, 11, 0, 0, 0, 11. Okay, this will be that A into I. Got it? What we have, that A is 11 and I is 1 0 0 0 1 0 and 0 0 1. So 1 is the diagonal element. In the place of 1 it will be 11 because it is multiplied with that A, right? So this is that A into I will be 11 0 0 0 11 0 and 0 0 11. Okay, so now we have to find what will be the multiplication of A into adjoint A. So A into adjoint A is, A matrix is 1 minus 1 2 3 0 minus 2 1 0 3. It will be multiplied with adjoint A, which is 0 3 2 minus 11 1 8 0 minus 1 3. So let's see what will be the result. So first 1 multiplied with 0 0, 2 multiplied with 0 0, minus 1 into 11 11. So first element is 11. Second 3 minus 1 minus 2, 3 minus 3 0. Okay. After that 2 minus 8 plus 6 0. 2 plus 6 8, 8 minus 8 it is 0. 3 0 0, 11 0 0, minus 2 0 0 0. 3 3 is 9, 0 1 is 0, 2 2, 3 3 is 9, 2 1 is 2, 9 plus 2 11. 3 2 is 6, 0 8 is 0, 3 into minus 2 minus 6, 6 minus 6 0. 1 0 is 0, 11 0 is 0, 3 0 is 0 0. 3 0 minus 3, 3 minus 3 0. 1 2 is 2, 0 8 is 0, 3 3 is 9. So 2 plus 9 11. So this is A into adjoint A is 11 0 0 0 11 0 0 0 11. So this is equal to our that A into adjoint A, right? That A into identity matrix. It is equal to that A into identity matrix, which is 11 0 0 0 11 0 and 0 0 11. So this is proved. A into adjoint A. Now we have to prove adjoint A into A. Adjoint A into A. So adjoint A into A will be 0 3 2 minus 11 1 8 0 minus 1 3. This is adjoint A. A will be 1 minus 1 2 3 0 minus 2 1 0 3. This is A. Okay. Now let's do the multiplication. 0 3 2. 3 3 is 9, 2 1 is 2. So first element will be 11. 0 minus 1 0, 3 0 is 0, 2 0 is 0 0. 0 2 is 0, 3 minus 2 minus 6, 2 3 is 6. So 6 minus 6 0. Now let's come to second row. Second row, first column, minus 11 into 1 minus 11. 1 into 3 is 3, 8 into 1 is 8, 8 plus 3 11, 11 minus 11 0. Minus 11 into minus 1 is 11, 0 0. So here it will be 11. After that, minus 11 into 2 minus 22, minus 22 minus 2 plus 8 3 is 24. 24 minus 2 is 22. 22 minus 22 is 0. Here it will be 0. Let's come to third row. 0 1 is 0, minus 3 plus 3, 0. 0 minus 1 0, 0 0 0. 0 2 is 0, minus 1 into minus 2 is 2. 2 plus 3 3 is 9, 9 2 plus 9 is 11. So this is also 11 0 0 0 11 0 0 0 11. Okay. So this is also equal to that A into I. So we proved that this is equal. So all three are equal, right? A into adjoint A equal to adjoint A into A equal to that A into I. Okay. So this completes problem number 2. Let's move on to problem number 3. Let's move on to problem number 3. This problem is based on inverse. Okay. So for inverse, we need to find adjoint also. So what is the inverse formula? Inverse formula is A inverse is equal to 1 by delta A into adjoint A. So A inverse is 1 by determinant of A into adjoint of A. So this is the formula to find the inverse. So what is that A over here? That A is 2 into 3 6, 6 plus 8 14. Okay, 2 3 is 6 plus 8 14. So 14 is that A. Now what is adjoint A? Adjoint A is cofactors transpose. So cofactor for 2 is 3, minus 2 is minus 4, 4 is 2 and 3 is 2. Okay, so these are the cofactors and we have to do the transpose of this. So this will become 3 minus 4, 2 and 2. So this will be the adjoint A. Right? What we have done, we have found the cofactors. For this cofactor will be negative, for this cofactor will be negative. For this element and this element. So that's why I have taken 2 and minus 4 over there. Right? So this will be the adjoint A. So what will be my A inverse? My A inverse will be 1 by that A is 14 and adjoint A is 3, 2, minus 4 and 2. So this will be my A inverse. Got it? Okay. Now this completes the problem number 3. Move on to problem number 4. Okay. In this problem number 4, we have to find the inverse of the 3 by 3 matrix. So 3 by 3 matrix is 2, 1, 3, 4, minus 1, 0, minus 7, 2, 1. Okay. So this is my A matrix. Now what is the inverse now? Inverse is 1 by that A into adjoint A. So let's find first what is that A. So that A for this will be, I will expand for row 1. So row 1 expansion it will be 2 into minus 1 minus 1 and second element it will be 4 minus 0. So it is 4 and after that final element it is 3. 3 it will be 8 minus 7. So it will be minus 6 plus 3 equal to minus 3. So determinant is minus 3. Okay. By the expansion of the first row we got it as minus 3. We can expand to any row and any column. We will get same determinant. So we found that A. What will be my adjoint A? My adjoint A is cofactors transpose. So let's find the cofactors for this matrix. Cofactor for 2, it will be minus 1, minus 0, so it will be minus 1. Positive, so it is minus 1. Second, it will be negative. So first row, second row you have, second column and first row you have to take it out. So it will be 4 minus 0, so 4, and it is negative, so it is minus 4. Now for 3, the cofactor will be 2 4s are 8, 8 minus 7 is 1, so it is 1. Now this will be negative, here it is positive, so here it will be 1. Okay. Now here for 4, it is the cofactor will be negative, so it will be negative of the minor. So minus and so it will be 1 minus 6, so it is minus 5, so it will be 5. Okay. 1 minus 6 minus 5, so it will be minor is minus 5, so it will be 5. It will be positive here for minus 1. So it will be 2 plus 21. Okay, so 2 plus 21 is 23. So 7 3 is 21 and here it is 2. So 2 plus 21, it is 23. Now for 0 it is negative, 2 to the 4, 4 plus 7, 11 and it is negative, minus 11. For minus 7, positive, 0 plus 3, so it will be 3. For 2, negative, so it will be 2 minus 0 minus 12. So it will be 12 because it is negative. So it will be 0 minus 12. So minus is multiplied again. So it will be 12. Yeah. Now for final element for 1 it will be minus 2 minus 4 minus 6. So it will be minus 6. It is positive. So it will be minus 6. These are the cofactors. So cofactors transpose you have to do. So it will be minus 1, minus 4, 1, 5, 3, 23, 12, minus 11 and minus 6. So this will be adjoint A. What will be my A inverse? My A inverse is 1 by that A into adjoint of A, right? So it will be minus 1 by 3 into adjoint of A is minus 1, 5, 3, minus 4, 23, 12, 1, minus 11, minus 6. So this is adjoint A. Now what we will do? We will consume negative inside. Okay, so it will become 1 by 3, 1, minus 5, minus 3, 4, minus 1, minus 23, minus 12, 11, 6. So this will be my A inverse. Okay, so this completes problem number 4. Let's move on to problem number 5. Okay, let's move on to problem number 5. So problem number 5 says we have to find the inverse of this 3 by 3 matrix. Okay, so for this 3 by 3 matrix, what will be the that A? That A will be, I will expand through first row. In first row there is 1. Okay, so it will be minus cos square alpha minus sin square alpha, minus cos square alpha minus of cos square alpha minus of sin square alpha. After that it is 0, so it will be 0, plus again there is a 0 element, so it will be 0. Minus you take totally common, so it will be cos square alpha plus sin square alpha. So you will get it as minus 1. Cos square alpha plus sin square alpha is 1. So it is minus 1. We found that. Now determinant. Now we have to find the adjoint. So what will be the adjoint of A? Adjoint of A will be, for 1, it will be minus cos square alpha minus sin square alpha. So it will be minus 1. Okay, minus cos square alpha minus sin square alpha, it is minus 1. For 0, it will be 0. For this 0, it will be 0. For this 0, it will be 0. For cos alpha, it will be minus cos alpha. Okay, you do this, then it will be minus cos alpha and it is positive. Okay, for sin alpha, it will be minus sin alpha because it is negative, for negative of the minor. So minor of sin alpha is sin alpha. So it will be minus sin alpha. Right? Now for this 0, it will be 0. For sin alpha, it will be it will be sin alpha minus 0, so sin alpha. And for this it is negative, so it will be minus sin alpha. Okay, and this one is positive, and for positive it is cos alpha, so it is cos alpha. Okay, so this will be the adjoint A, and we have to take this cofactors transpose. So once we take this cofactors transpose, we will get minus 1, 0, 0, 0, 0, minus sin alpha, cos alpha, minus sin alpha, minus cos alpha. Okay, so this will be the transpose. So this is adjoint A, right? Now what is my A inverse? My A inverse is 1 by that A into adjoint of A. So this will become minus 1. That A is minus 1, right? So it will be minus 1. What is my adjoint A? Adjoint A is minus 1, 0, 0, 0, 0, minus cos alpha, minus sin alpha, minus sin alpha, cos alpha. You will consume this minus inside, so it will be 1, 0, 0, 0, 0, cos alpha, sin alpha, minus cos alpha. Okay, got it? So this will be my A inverse. This completes problem number 5. Let's move on to problem number 6. Let's move on to problem number 6. In problem number 6, A and B are two 2 by 2 matrices. A is 3, 7, 2, 5 and B is 6, 8, 7, 9. Okay, these are the two 2 by 2 matrices A and B. We have to verify that AB inverse is B inverse into A inverse. We have to verify that. Okay, so what we have to do? We have to do the product of AB and we have to do the inverse, and we have to do B inverse and A inverse, and we have to do the product, and we have to show that both of them are same. This is what the procedure of this problem. Okay, first AB will be 3, 7, 2, 5 and B is 6, 8, 7, 9. So 2 by 2 matrix, and this is 2 by 2 matrix, so result will be 2 by 2. So my 2 by 2 matrix after AB will be 3, 6 are 18, 7, 7 are 49, 49, 59, 59 plus 8, 67. So 67 is first element. 8 here 24, 7 and 63. 63 plus 24. How much it is? 24 and 63. 24 plus 63, it is 87. So it is 87. Okay. Now 2 6 are 12, 5 7 35. So 12 plus 35, 47. It is 47. Now 2 8 is 16, 5 9 is 45. 16 plus 45, 16 and 45. It is 11, 61. So it is 61. So this is our AB. Okay. Now to find AB inverse, we have to find that of AB. So that of AB will be 67 into 61 minus 47 into 87. Okay, so let's do that. So 67 into 61, how much it will be? 67, 42, 36 plus 4, 40. So it is 4087. So this is 4087 minus 47 into 87. How much it will be? 47 into 87. 7 7 are 49. 7 7 4 28. 28 plus 4 32. Into 7 8 plus 56. 8 4 32. 32 plus 5 37. So it is 9804. 4089. This is 4089. So 4087 minus 4089. So that of AB will be minus 2. Okay, are you getting it? That of AB will be minus 2. What is adjoint of AB? Adjoint of AB will be cofactors transpose. So what is the cofactor of 67, 61? 87 is minus 47 and 47 is minus 87 and 61 is 67 and transpose of this. So it will become 61 minus 87 minus 47 and 67. So this is adjoint of A, right? My debt is minus 2 and adjoint of AB is that, so AB inverse as whole, it will be minus 1 by 2, 61 minus 87 minus 47 and 67. Okay, if you want to consume minus inside, you can consume minus inside, then it will become half of minus 61, 87, 47 and minus 67. So this will be my AB inverse. Okay, right. So we found AB inverse. Now we have to find B inverse and D inverse. After that we find A inverse and we have to multiply both of them. So I will rub this out as we have completed this step. So not required. So we need only AB inverse now, right? Okay. Now first we will do B inverse. So B matrix is 6, 8, 7, 9. What will be my debt of B? Debt of B will be 6, 9 is 54 minus 7, 8 is 56. So it is minus 2. So debt of B is minus 2. What is adjoint of B? Adjoint of B is 9 minus 7 minus 8 6 transpose, which is equal to 9 minus 7 minus 8 6. This is adjoint of B. What is B inverse? B inverse will be 1 by det B into adjoint B. So minus of 1 by 2 into 9 minus 8 minus 7 6. So this is B inverse. Now I will find A inverse. For A inverse, what is that of A? That of A will be 3 5 is 15, 7 to the 14, 15 minus 14, this is equal to 1. Right? What will be my adjoint of A? Adjoint of A will be 5 minus 2. Okay. 5 minus 2 minus 7, 3 transpose. So it will be 5 minus 2 minus 7, 3. So what will be my A inverse? My A inverse will be 5 minus 7 minus 2 and 3. So this will be my A inverse. Determinant is 1. So 1 by data into adjoint A. So it will be my A inverse. Now I have to perform B inverse into A inverse. B inverse into A inverse. This is my RHS. Okay. So for RHS B inverse into A inverse, it will be minus 1 by 2, 9 minus 8 minus 7, 6 of the A inverse is 5 minus 7 minus 2, 3. Okay. Got it? Okay. Now we will do multiplication. 9045, 8 to the 16, 45 plus 16, 61, 9 7 is 63, 8 is 24, 24 plus 63, 24 plus 63 is 87, okay, and it is minus, so minus 87. 7 5 is 35, 6 2 is 12, so minus 35 minus 12 minus 47, and 7 7 is 49, 6 3 is 18, 49 plus 18 is 67. Okay, so this is 67. If you consume minus inside, then it will be 1 by 2 minus 61, 87, 47 minus 67. Okay, so this will be my B inverse into A inverse, right? This is my B inverse into A inverse. This is my AB inverse. So both of them are same, right? Both of them are same. Okay, so it is verified that AB inverse is B inverse into A inverse. This completes problem number 6. Let's move on to problem number 7. Okay, let's move on to problem number 7. So what problem number 7 says is if A is a matrix 3, 2, 1, 1, then we have to find the number A and B such that A square plus AA plus BI is 0. Okay, what is that? A square plus AA plus BI is 0. Okay, so we will do that now. First we will find what is A square. So what is my A square is 3, 2, 1, 1 and 3, 2, 1, 1. This is my A square. So 3 3 is 9, 9 plus 2 11, 3 2 is 6, 6 plus 2 8, 3 so 1 1 1 3 is 3 plus 1 4, and 1 2 is 2 and 1 1 is 1, so it is 3. So this is my A square. Okay. Now A and B I know. So now let's write this equation by replacing the values of A square, A and I over here. Okay. So what I will do, first I will write A square. So A square it is 11, 8, 4, 3 plus A into matrix A 3, 2, 1, 1 plus B into I. So B into 1, 0, 0, 1. This is equal to 0. Okay. Now we will write in the form of single matrix. We can write it 11 plus 3A plus B. So it will be 11 plus 3A plus B. First element will be 11 from here, 3A from here and B from here. Next element will be 8 plus 2A. It is 8 plus 2A. Okay, here it is 8, here it is 2 and here it is 0. So not required. Now 4 plus A, this element will become 4 plus A. What is this element? It is 3 plus A plus B. So it is 3 plus A plus B. And this is equal to 0. Right? This 0, I can write a 0 matrix over here of 2 by 2. Because it is also 0, 0, 0, 0, 0. Okay. Now what we will do? We will compare each and every element. So 11 plus 3A plus B equal to 0 and 4 plus A equal to 0. Two variables are there, so two equations are sufficient. So what is the value of A from this? This implies A equal to minus 4. Okay, this implies A equal to minus 4. You put A equal to minus 4 here, then you will get B equal to 1. So what is the value of, it will be minus 12 plus 11 minus 1, so it will go that side, so B equal to 1. So A equal to minus 4 and B equal to 1. Now we will just substitute over here, so minus 4 plus 1 it will give 0 and here you will substitute minus 4, it will be 0. Okay, so that means this completes problem number 7. Let's move on to problem number 8. Let's move on to problem number 8. What problem number 8 says, if A is a matrix, where 3 by 3 matrix, where it is 2 minus 1 1, minus 1 2 minus 1, 1 minus 1 2. If this is the A matrix, then we have to verify that A cube minus 6A square plus 9A minus 4I is 0. And we have to find A inverse. Okay, so let's do that. First we will find A square. So what will be my A square? It will be 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 into 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. So you do A square, so it will be 2 to the 4 5 and it is 6. So it will be 6 again minus 2 minus 2, minus 1. Minus 2 minus 2 is minus 4 minus 5. Okay, minus 2 minus 2 minus 4 minus 4 minus 1 minus 5. After that 2 1 2, it is 5, right? 2 1 and again 2. So 2 plus 1 3, 3 plus 2 5. Now going to second row, minus 2 minus 2 minus 1. Minus 2 minus 2 is minus minus 2 minus 2 minus 4 minus 4 minus 1 is minus 5. 1 4 and 1, so it will be 6. Minus 1 minus 2 minus 2, so minus 5. 2 1 2, 2 1 2 5. After that minus 1 minus 2 minus 3 minus 3 minus 2 minus 5. 1 1 4 6. 1 plus 1 2, 2 plus 4 6. So this is my a square. Now my a cube. A cube will be a into a square, so it will be 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. So this is my a cube into a into a square. It will be 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6. Okay. Now we will multiply these two. So you will get 12 plus 5 17, 17 plus 5 22. So this is equal to 22. Now 2 minus 5 is minus 10, minus 10 minus 6 is minus 16. Okay, minus 16 minus 5 minus 21. Now 2 5 are 10, 10 plus 5 15, 15 plus 6 21. Minus 6 plus minus 10 minus 16, minus 16 minus 5 minus 21. Minus 1 into minus 5 5, 5 plus 12 17, 17 plus 5 22. This is 22. Minus 5 minus 10 is minus 15, minus 15 plus minus 5 minus 10 is minus 15, minus 15 minus 6 is minus 21. 6 5 11, 11 plus 10 21. It is 5 plus 5 10, 10 plus 12 22. Wait, this is minus 21. 1 minus 5 minus 6 minus 11 minus 11 minus 10. So I missed the second column. So it is minus 5 minus 6 minus 10. Minus 5 minus 6 is minus 11, minus 11 minus 10 is minus 21. 1 5 5 10, 10 plus 12 22. So it is 22 here. So this is a cube, right? So this will be my a cube, that will be my a square. So just substitute in this equation, then it will be a cube. So it will be 22 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22, a cube. Okay, minus 6 into a square. A square will be this, so it will be 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6 plus 9a. 9 into, what is a? A is 2 minus 1, 1. After that minus 1, 2 minus 1, 1 minus 1, 2. Minus 4i. 4 into I will be 1 0 0 0 1 0 0 0 1. So this is the equation of a cube minus 6a square plus 9a minus 4i. Okay, so what we will do, we will take each and every element now. 22 minus 36. First element is 22 minus 36 plus 18 minus 4. So it will be, where I will write? I will write it over here. So I will rub this out. This is not required. This is also not required. Thank you. So, this is a square and this is a cube. Okay. So 22, first element will be 22 minus 36 plus 18 minus 4. Second element minus 21 plus 30 minus 9. Okay, minus 9. And third element will be 21 minus 30 plus 9. Okay, so what I am doing? I am doing each and every element and I am writing it over as the operations between the numbers. Now, minus 21 plus 30 minus 9, 22 minus 36 plus 18 minus 4. Last element is minus 21 plus 30 minus 9 and last element is 0. Other that element is 0, 4 into 0. This one will be 21 minus 30 plus 9 and 0. After minus 21 plus 30 minus 9, 0 it is there. Again it is 22 minus 36 plus 18 minus 4. Okay, now 22 minus 36 plus 18 minus 4. Minus 36 plus 18 is minus 18 minus 18 minus 4 minus 22 minus 22 plus 22 0. Similarly, this will become 0, this will become 0, right? Because same thing, 22 minus 36 minus 18 plus 18 minus 4 plus 18 minus 4. Minus 21 minus 9 minus 30 plus 30 0. 21 plus 9 30, 30 minus 30 0. Minus 21 minus 9 is minus 30 plus 30 0. Minus 21 minus 9 minus 30 plus 30 0. 21 plus 9 30, 30 minus 30 0. Minus 21 minus 9 minus 30 plus 30 0. So this entire matrix has become 0. Okay, so we have proved that this is equal to 0. Okay, now by using this we have to find the A inverse. So how to find the A inverse now? Okay, so I will rub this out. So you understood this, how it becomes 0? So this entire thing is becoming 0. Now for A inverse, what I will do? I will multiply entire equation with A inverse. Once I multiply entire inverse with equation with A inverse, this will become A square, this will become A, this will A inverse into A, it will become I, and minus 4 into A inverse it will become. So I will write it. So it will be A square minus 6A plus 9I minus 4A inverse equal to 0. Right? 4A inverse I will take it that side. So 4A inverse equal to A square minus 6A plus 9I. Okay? Right. Now what is A square? 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6. This is A square. Okay. What is my 6a, a is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and so somehow a cube is not required, so I am taking this out because a cube had become a inverse, so now there is no role of a cube in the equation. Okay, we had found a cube wherever it is required. We had used the a cube in the equation, so now a cube is not required. Okay, I got that. Next, 9, I is 1 0 0 0 1 0 0 0 1. Okay, so this will be my 4a inverse. Okay, so now I will perform the operation now. 6 minus 12 minus 6 minus 6 plus 9 3. So first element is 3. Minus 5 plus 6 1, and there it is 0, so it is 1. Okay, minus 5 plus 6 is 1. 5 minus 6 minus 1, so it is minus 1. Minus 5 plus 6 1 and 0, so it is 1. 6 minus 12 minus 6 minus 6 plus 9 3, and minus 5 plus 6 is 1 and 0, so here it is 1. 5 minus 6 is minus 1, and there it is 0, so it is minus 1. And 5 minus 5 plus 6, sorry 5 minus 6 is minus 1, yeah, correct. Okay, next is minus 5 plus 6 plus 0. Minus 5 plus 6 is 1, and plus 0 is there. 6 minus 12 minus 6 minus 6 plus 9 is 3. So this is 4a inverse, right? This will be my 4a inverse. So what is my a inverse? My a inverse is 1 by 4, 3 1 minus 1 1 3 1 minus 1 1 3. So this will be my a inverse. Okay, so we found a inverse by using this equation. What we have done in this equation, we have multiplied with a inverse. Once you multiply with a inverse, this I in the inverse will be a inverse 9i 6a, and it will become a square. And we had kept the values of that, and we got what is the value of a inverse. Okay, this completes problem number 8. Let's move on to problem number 9. Let's move on to problem number 9. So problem number 9 says if A is a non-singular matrix. Okay, non-singular matrix means determinant of A is not a 0. Okay, then that means what will be the order of adjoint A? So they are asking what is the order of adjoint A. So there is one formula that of adjoint A equal to that of A to the power of n minus 1. This is the formula. That adjoint A is equal to that of A to the power of n minus 1. What is n over here? N is the order of the matrix. So what is the order of the matrix of here? It is 3, and it is a non-singular matrix, that means determinant is not a 0. Okay. So here the order is 3. So n value we will replace it with 3. So it will become that A to the power of 3 minus 1. So it will become that A square. So this is option B. Okay. So what the problem was asking? Problem was asking is A is a non-singular matrix of order 3 by 3. Then that of adjoint A. So that of adjoint A will be equal to that of A square, determinant of A square. Okay. How? By using this formula. Right. So this completes problem number 9. Let's move on to problem number 10. Okay. Let's move on to problem number 10. So problem number 10 is A is an invertible matrix of order 2. Invertible matrix means determinant is not 0. Okay, it is a non-singular matrix. So we have to find the determinant of A inverse. What will be the determinant of A inverse? For this, we have to use logic that A into A inverse is equal to I. Okay, we know that A and A inverse, if you will multiply, it will become I, right? Now, that of A into A inverse will be equal to that of I, determinant of I, right? So it will become that of A into that of A inverse equal to 1. So determinant of I is 1. So what is determinant of A inverse? Determinant of A inverse is 1 by determinant of A. Okay, you understood this? Determinant of A will go to RHS, then it will become 1 by determinant of A. So answer is B. Okay, so this completes problem number 10. So what we had done in our workshop session 9, in this workshop session 9, we had completed the problems based on adjoint and inverse from NCERT. We had covered most of the problems of the NCERT. If we had not covered anything, that means we had seen certain similarities in that question. You should go and solve those problems by your own. Okay? If you are having any doubts, please comment. Okay? If you are happy with the video and today's content, then please press like, share and subscribe. For the further questions in the matrices and for the further videos, please stay connected. Thank you.